Yes, SW ma'am, I have a question related to the test. Will you be posting like any revision exercises or a past year paper for us to work with?
I don't do past question papers. But if you want question papers, the only papers that may be available to you are the ones posted by the library. If they have, then those are the only ones. In terms of from my side, I don't share question papers. The reason for not doing that is because the we sometimes have online. Secondly, the book that you have, it's mostly theory. So if I am going to be sharing question papers, it means that I, on the other side, I end up having nothing to ask because probably you have everything that can be asked from the book. So I teach the way I teach because I try to make sure that you have all the understanding, and I already highlighted that some questions might be application based. I explained that from the beginning. It's because of that, because of online. Sometimes it's online. We need to make sure that students don't plagiarize or cheat in any way. Then we have limitations in terms of what can we share and what can we not share. So I don't share question papers, past question papers I don't share. But I'm always available to answer any queries, any questions that you might have. If, for example, when we were doing sieve analysis, the example that I did, it was not the example that you have in your book, right? So you have already an example in your book. I did cover another example. Feel free to refer to any additional books you can find in the library as well. They might have. They do have your sieve analysis and everything that is covered in the subject, so you can refer to that. But remember, because it's mostly theory, it might be different. So the line of questioning and everything might be different. So that's why I'm saying I normally advise that when you study, don't study to cram, study to understand it, so that if a question comes in any way, you're able to apply. So the type of questions that you would normally get, your subject is NQF level 6. It means that you get to be asked questions in a certain way, right? So it's not, you don't expect list, define only. And I've never asked people to list, but I do ask you, maybe define this and maybe discuss, right? Something like that. So when you look at a topic or you're studying something, just make sure that you understand it, because maybe you might be given a case study, right? Just a little bit, a small case study, and you are asked with your knowledge maybe on stabilization, which is something that we're going to cover. What do you think in this scenario a solution might have been? Something like that. So look at it that way. So when you study, just remember you're studying to get the knowledge, and then you're going to apply that knowledge in that sense. So when I say application-based questions, those are the kind of questions I'm talking about. That example that we did the last time was the one where we spoke about minerals and right. You remember that example. So it's something like that. I will try as much as I can every time to remind everyone that in everything, study, but also remember, if an application-based question comes in a form maybe of a case study, and maybe discuss thoroughly what is your understanding about something, you are able to explain it. Gemsan, I don't know if I'm saying your surname correctly, but I saw your hand. Do you still want to ask something?
Sorry, ma'am, there was a mistake.
Okay, no problem. Thank you very much then. Okay, let's just go into the into what we are supposed to do today. And then I think I'll stop at least 10 minutes before the end so that you're able to ask questions if you might have any. But in any way, remember, once I'm on presenting mode, I can't see the hands. So just feel free to stop me if there's a need or there's something that you would want to understand. You do see my screen, right? Yes.
Yes, ma'am.
Okay, thank you very much. Like I said, the chapter that we are going to focus on today is soils. We've already covered geology part, whereby we kind of understood where does the soil come from, right? And we even touched on a lot of things based on where does it come from. So the things that you need to take note of, or the learning outcomes of this specific chapter, is the origin of soil, the identification of soil. You need to know how to classify, or the classification of soil. What do we mean by that? Soil survey procedure or site investigation, quarries, stabilization, slopes, reinforced earth. All this information, when you look at it, it's based on soil, right? So remember we said this is how soil forms. We're going to look at its origin. Now that we know where is it coming from, how do you identify it, and then how do you classify it? Finally, when you go on site, what's a soil survey procedure and what do we look into? And are there any tests, specific tests that we need to know or take note of when it comes to a site investigation? We will look at quarries and find out what are they and how are they important. Stabilization of soil, slopes, what do they mean by slopes, and why are we concerned about slopes? And finally, the last topic that we need to look into is the reinforced earth, right? So they say soil is important and is an integral part of any civil engineering project. It has many uses, and understanding some of its basic properties and behaviors can help engineers make informed decisions during planning and constructions. Like we said, it's important for you to understand soil. When we started, I said it's important because before you start any project, or any project that we normally take, we construct or we build on soil, right? And therefore understanding the soil properties and its behavior meaning when exposed to maybe water or environmental conditions, that type of soil that you have there, how will it react? And what does that mean about the stability of the soil or the foundation, right? Because the foundation is the one that supports all the loading that comes from the top, and then those loads are transferred into the soil. So it's important for you to understand that this soil, it has these properties, and when exposed to different conditions, this is how it's going to react. Then you need to understand fully the type of soil. And then we even went and said we have different types of soil. We spoke about clay soil, sandy soil, we spoke about gravel, we spoke about silt. So those are different types of soils that react differently when exposed to either water or environmental conditions. And therefore, it means that the stability of the soil might be affected depending on what the soil is experiencing. And then I just have a note, remember the uses of what? The uses of soil. When we did geology, the last part of it that we covered, I told you we have igneous rocks, this, but towards the end, and then we kind of narrowed it down and said, it's important for you to understand all these because we use rocks or soil in different forms when it comes to civil engineering. And we listed that. We said sometimes we build with them, we make cement out of soil, all those uses these are the ones that I'm referring to when I say remember the uses. The uses of what? Of soil. Where did we learn about them? We learned about them in the chapter of geology. It's still important because you are going to move with that information moving forward. So just remember that. So they say for engineering purposes, soil is to be considered any loose deposit such as gravel, sand, silt, clay, or a combination of the materials. So what happens is you have all these different types of soil that we have. Sometimes it can be a combination of these. So maybe you'll find that it's gravel mixed with clay, or sand mixed with clay, or clay mixed with silt, right? So that's why when they say a combination of the materials, that's what they are referring to. And the first thing that you need to know is on the surface, on the surface, when you look at the surface of the earth, right? What you see there is what we call topsoil. We don't build from on topsoil. So for any engineering project to begin, what normally happens is they will remove the topsoil. They remove topsoil because topsoil, it's where, in terms of the condition, environmental conditions, they're harsh at the top, right? So they will remove the layer of the topsoil, and then if there are any tests that need to be made, we consider the layers from that. So the topsoil is where we'll normally plant things, and you see vegetables or flowers or whatever. So that's a part of topsoil. But if you're trying to build something, you're building from a layer below the topsoil. So that's what you need to take into consideration. The type of soil, when we are referring to the type of soil, they say soil can either be fine or coarse-grained. Fine, remember, we're talking about soil that is fine. If it's coarse-grained, it means that it's coarse, right? When we're talking about fine, remember, it's different from soil fines. Just a reminder, please make sure that you are muted. Please make sure that your mics are muted. I'm getting feedback from someone, I'm not sure. So they say that they consist of solid particles, water, and air voids, right? So this is a soil profile. On the diagram that you see on the slide, it's a soil profile. When you see it with your naked eye, this is not what you see. So this is an arranged soil profile, whereby at the bottom, they have the solid particles, which is the brown layer. The blue layer is the water, and then the white layer is air, right? So when we talk about soil, we can either refer to it in terms of volume or in terms of mass. So on the left, you'll see VT, which denotes total volume. VS is the volume of solids. VV is the volume of voids. VW is the volume of water. VA is the volume of air. On the right side, there is MT, which is the total mass. MS, mass of solids, and MW is the mass of water. Right. So when you look at soil, right? So if you get soil from site, it can either be dry or moist, right? If it's moist, it means that it will have the solid particles, water, we refer to that as the moisture content, and then it will have air in it, the voids, right? And then if it's dry, completely dry, it will only have solid particles and air. Anything relating to that, we will find out how do you find out the amount of moisture in soil as we move forward in the presentation. So they say strength is a very important factor, right? Thus, the removal of voids for increased density. What are they talking about? That's when we will be looking at compaction. So they say, since we are focusing on strength, right? Because we're going to build on it, and therefore we're going to impose loads on that particular section of soil. What do? We need to make sure that we remove all the voids. To do what? To increase the density of soil. We already covered and said density of solid particles might differ depending on was the rock formed intrusively or extrusively. But they say in a collective, when you're looking at a particular soil in a collective manner and you want to build on that, on top of that soil, we focus on strength. We achieve that by removing the voids. How do we do that? We compact the soil, right? So they say moisture is vitally important. Too little water causes excessive friction, and too little causes excessive friction, and too much causes solid particles to swim. Good compaction is dependent on the correct amount of water. If you have soil and you want to remove the air voids, right? So just think about this. If you have soil that is completely dry and you add just a small amount of water, right? In terms of what are you trying to do? So all of these things are interconnected. Why do I say that? We said that when we do a sieve analysis, we're trying to make sure that all solid particles, big, medium particles, and smaller particles are represented. Why? Because when we are trying to do the compaction process, we're trying to make sure that we remove all the air voids. So all the spaces will be filled with the medium particles and the smaller particles, and therefore we have a closely packed layer of soil. They tell you that if you add a small amount of water, then you're going to experience excessive friction, and therefore it does not lead to good compaction. But at the same time, if you add too much water, it means that you're going to have particles that are swimming in water, and therefore we are not going to get what we are.
Hi, ma'am.
Okay, I'm very sorry for the disturbance. I'm very sorry for the disturbance, and I've tried as much as I can to limit the settings. So what's going to happen is you will only be able to ask questions towards the end, right? Thank you very much. I'm sorry for the disturbance. We can continue then. Feel free to write all the questions that you might have on the chat, and then everything, just write it there. I will read your question and answer it. But in terms of limiting the settings, I've made sure that yeah, we limit everything as much as we can. The other students then will be able to access this recording online. So I will continue with the presentation.
Ifunda kanjani silambile?
Wathule ngathi awucabangi wathule ngathi awucabangi ngathi awucabangi.
Hello Lefaita.
Namaxoki ifunda kanjani silambile?
Jaffa, we are hungry.
So then I'm going to continue. So we were saying that to make sure that you get good compaction, what you need to do is to make sure that you limit water in terms of it must not be too little and it must not be too much for you to get good compaction. So that's the first thing we need to take note of. Just a minute. Let me just okay, just wanted to mute all my notifications so that I won't get any notifications coming in because they are disturbing me. All right, so we were saying that we need to make sure that we have good compaction. That's number one. So for you to get good compaction, what do you need to do is you need to make sure that you limit the water. You don't get too little and you don't get too much. So that's number one. Right. So we have what we call in terms of the identification of soil, right? So we're talking about soil, and then we are saying when you're looking at identification of soil, right? We say soil can be identified by looking at its physical characteristics, and these are other ways soil can be identified by in the field, right? So we say that we have ways you can identify soil in the field. So they look at compressibility, plastic characteristics, the dry strength of soil, its color, the smell and feel, right? In terms of the explanation, I tried to explain on the side, what do I mean or what do they mean by that? But if you go to your page, they discuss it thoroughly in terms of what do they mean. So in terms of compressibility, what they say is you will hold and squeeze the soil. If it reacts in a certain way, then for example, maybe if it reacts in a certain way, if it has water in it or it does not have water in it, then that means something about the soil. That's number one. Plastic characteristics, they say you roll and shape it, and they focus mostly on the cohesiveness. When you look at this characteristic, it will mostly relate to soil that has clay in it. For soils that does not have clay in it, they don't have plastic characteristics, and therefore they will tend not to react in a certain way when you either roll it or shape it. The dry strength of soil, you squeeze and you break the soil. In terms of color, they say, is the soil black colored or light colored? When we were discussing this in geology, remember we said the black or the lighter color of soil is not really a strong property that you really look into when you look at the soil, because it might mean sometimes that the soil is maybe contaminated. That's why it's black. So in terms of the color, you look at it and you need to make sure that you do other tests as well before you classify that soil into a certain group. Smell, a distinctive smell after disturbing the soil. If the soil is contaminated, it will have a different smell, and then other soils that are not contaminated might not have. The feel, you touch and rub the soil in your hand, and then how it reacts then tells you something about the soil. For further discussion on the field identifications, feel free to go to page 6 of the PDF document that I gave you. if it does not show that it's page 6, just look at it at the top and it will say field identification. Then you will have all these physical characteristics, and then they explain them thoroughly. What do they mean by each and every one of them? Now, when you're going to collect the soil sample on site, right, you can collect it in 2 ways. The soil can either be disturbed or undisturbed, right? So a soil that is disturbed, example, we're going on site and then you just take a shovel and then you start disturbing the soil, or you start collecting the soil. That's it. An undisturbed sample is whereby we try as much as we can to not interfere with the soil. So maybe you'll have a cylinder shape, you will drill it down the layer of soil and then try to extract it as it is, right? Either maybe a cylindrical shape or a cube or any form whereby the sides, you're kind of trying to control the disturbance. So that's the difference. For the disturbed one, just look at it like it's a shovel, and then you are just randomly taking the soil and putting it into a container. That's it. And then the disturbed one, the undisturbed one, is whereby it's kind of controlled. When we go to do practicals, I will show you the difference when a soil sample is disturbed and which one is undisturbed, so that maybe if whatever it is that I'm saying does not really make sense now, it will make sense then. Right. So the other thing that we look into when it comes to the identification of soil, it's its consistency. The consistency is that property of soil that displays resistance to flow. It reflects the cohesive abilities of the soil. Water is a huge factor. Soil moves into different stages depending on water added. Which stages are they talking about? The liquid stage, the plastic stage, and the solid stage, right? So on the book, you also realize what I'm talking about. They have a graph whereby they show you that soil moves from being solid, semi-solid, plastic, and then liquid, right? So it moves. So they say consistency is that property that it will resist to flow, right? So they say that consistency is expressed using 3 limits. The limits that they're talking about is the liquid limit, the plastic limit, and the shrinkage limit. This we deal with it deeply in geotechnical engineering 2B. It's a subject that you're going to do second semester. But for now, so when it comes to consistency tests, they talk about those 3 limits, being the liquid limit, the plastic limit, and then the shrinkage limit. And then they just tell you here that the liquid limit is the moisture content expressed as a percentage by weight of the oven dry soil at the boundary between the plastic and liquid. It might not make sense right now, but I will explain when we are at the lab. The plastic limit, moisture content of the soil at the boundary between plastic and solid. And then the plasticity index is a value used in conjunction with the liquid and the plastic limits. It's the difference between liquid limit and plastic limit. But in depth, I will explain just, we'll explain simply what do they mean by these and how do they achieve those moisture contents that they're saying it's a boundary between this and this and that. And then in terms of when are you going to go into it, you will do it second semester. So when it comes to consistency, what do you need to note is that the soil will flow when it has water in it. So when we add water into soil, it will flow, right? So if it will flow or it will change, it will move from a solid state to a plastic state and to liquid state. In between those, for you to test the consistency of soil, you do it using 3 limits. What are those 3 limits? The liquid limit, plastic limit, and the shrinkage limit. And then they talk about the specific gravity, and then they say the specific gravity is the ratio of the weight of solid material per unit volume to the weight of an equal volume of water under standard conditions. So normally what happens is the specific gravity of water, it will always be 1 because the density of water is 1,000 all the time, 1,000 kilograms per meters cubed. You need to know that. And the specific gravity of water is 1, right? The specific gravity of aggregates will be different, right? So they say most coarse aggregates used in road construction have values ranging from between 2.65 and 2.7. So the specific gravity will be given, or you will need to determine using a formula sometimes. When do we cover that? Second semester as well. So now what you just need to know is there is what we call a specific gravity, and then a hydrometer test is used to determine the value. For water, you need to note that the specific gravity is 1, and for aggregates, it might differ from 2.65 to 2.7. In terms of how do you calculate it, we don't cover it in this semester, we cover it second semester. So in terms of information purposes, then you need to hold the information that I just shared, right? So we also have in terms of identification of soil, we're still in a section whereby we are trying to understand how do you identify soil. They touch on the soil volume characteristics. Soil volume characteristics, it simply means that the soil will shrink or swell. When will it shrink and when does it swell? Or the shrinking part is the one where we are talking about the compacted. So let me make an example. You have soil, right? You have okay, you have a site, right? And you want to do a test. You disturb the soil. Remember, you disturb the soil because the sample can be disturbed or undisturbed. You disturb the soil and then you extract that soil sample. That soil sample, you have the soil in a bank form. They say this is the soil in its natural state. It's undisturbed, right? So it will be that soil, that site as it is. Immediately when you extract or when you disturb the soil, it becomes loose. The loose material after excavation. So this is when the swelling takes place, right? I'll make an example. If you have if you have a site, you are disturbing the soil. What happens is, if you take the same soil that you had, just visualize this. You have a site, and then you start digging, and then maybe you dig a hole. You take the same soil that you just excavated from that hole. What normally happens is there will be leftover soil on the side if you did not compact the soil into the hole. What does that mean? It means that the soil from its bank condition moved to being in a loose condition and it swelled. But if we take the same soil, we take it in small portions, we take it back to the hole, but before you add another layer, you compact it. So it means that you are removing the voids and you're making sure that the soil is in a compacted state whereby it will be reduced volume and therefore higher density. So in terms of soil volume characteristics, they are simply saying to you, soil will move from different conditions, either being in a bank condition, loose condition or a compacted condition, depending on where. So when you are just looking at it and the site, you have not excavated anything. That soil in its natural state is in a bank condition. If you disturb it and then maybe you dig a hole, that's when they say excavation. You excavate or you dig a hole, it will change from a bank condition to a loose condition. This is a place whereby swelling will happen. The compacted condition is when you have that soil, maybe it's excavated, but you want to close back that hole. What do? You take back the soil, but you don't just transport it from that heap to the hole. What do is you take it in small layers and you compact it. So that's the difference. And then soil volume characteristics, they talk about swelling or bulking. They say it's increase in volume due to excavation. We just discussed this. Shrinkage is the decrease in volume when compaction takes place. The load factor is changing or converting loose to bank condition, right? And the shrinkage factor is you're changing or you're converting the bank condition to a compacted condition. So just take note of those. This part in the textbook has a calculation attached to it. Because now you do have a sample of what we're going to have in the book. Just go through it thoroughly, and then in our next session, when we kind of conclude the chapter and we conclude the sieve analysis portion, we will also include this portion of the calculation so that you understand what are the calculations relating to how do you calculate the loose condition, the soil or the volume in its compacted condition or in its loose condition, and how do we then determine, or how does the load factor and the shrinkage factor come into play? So it's a part that we'll also cover. Under the soil identification, we will be done with how then do you identify soil, and we move to something, and then they say this is a soil classification, right? Classification systems are passed on particle size found in the soil mass. Classification systems is used for the following: identify different groups, provide the same language for soil investigators. It's used as a basis for decision on further tests required for solving engineering problems. Okay, what's a soil classification, right? When they talk about soil classification, basically what the slide is saying is we have a way to classify soil, right? It will be easier for you to remember because you already know that when we are doing a sieve analysis, we will have a part whereby they say gravel, sand, silt, and whatnot. What's happening there is that soil is classified into different groups, right? So they have different classification or classification systems, right? So different places will use different methods of classification. In South Africa, we mostly use the Casa Grande and the Unified Soil Classification System. So you will look at soil and say it has this, it has this, it has that, it has that, therefore it's this kind of soil. You look at it again, you say it has these particles, that this is how it looks, this is how it smells. When we are focusing on the tests that we're doing, this and that, and then you say this is how this is maybe clay soil or silt soil or gravel, right? So we have different tests that can be performed on soil, so that to ease the process of classification, because you remember the classification goes in different stages. So for coarse-grained, we focus on sieve analysis. So you can have a sample of soil, right? And then we do a sieve analysis on it. But on the same soil, we are going to do fine-grained tests. If that soil has soil fines, what are soil fines? Soil fines are all the particles that are smaller than 0.25 millimeter, 0.425 millimeter sieve. So you will have a coarse-grained test relating to sieve analysis. We know how to do a sieve analysis. But we also know that when we are talking about a sieve analysis, there's soil that will be collected on the pen. The fine-grained tests that are done on the fines, soil fines, normally include water. So we will add water in it. That is when you mostly focus on the consistency of soil, right? So remember I said when we were talking about the consistency, we said there are tests done to determine 3 limits: plastic limit, liquid limit, and shrinkage limit. Those tests are fine-grained tests whereby water will be added to the sample of soil and we will see how it flows. How does it change from solid to being semi-solid, being a liquid? So all of that information, it goes together in a sense of you will do all those tests because at the end of the day, what are you trying to do? You're trying to make sure that you classify the soil. Once the soil is classified, then you can make informed decisions on what do we do moving forward. Will the soil be strong enough or not? Is it strong enough? Yes, it is. Then we use it as is. We just compact. It's not strong enough. Maybe we stabilize it to improve the strength, or it's not suitable at all. We need to make sure that we get another type of soil to supplement, right? So there are different ways to decide, but the classification of soil comes into that because all the tests that you do, you don't just do them, you do them because you want to get to the end goal. The end goal is we're trying to find out, will the soil be strong enough or will the soil be suitable for the purpose? Maybe we want to build a strong structure on it, or we want to build just a house, right? So the loadings will be different depending on what do we want to achieve. And then the soil survey procedure or the site investigation. This refers to the preliminary engineering or site investigation. It is done to gather information on the soil and groundwater. Different apparatus will be used depending on the site and the specifications of the proposed building or road or any type of project. So what's a soil survey procedure? It's a soil survey procedure, or we also refer to it as a site investigation. Once you get news that we need to maybe build something, either a road, a house, or whatever, you visit the site. What are you going to do? You're going to do a preliminary study or survey. You will take your levels, you will take soil samples, all the information. You also look at the groundwater levels. Why are you looking at the groundwater levels? Because water will affect the foundation or the structure. Therefore, we need to know, do we need to design in a manner that we know that this foundation will be affected by water or not? Because depending on whether you are catering for groundwater or not, the type of concrete in terms of strength will differ. Therefore, that's why it's important that before you even do anything, you do that preliminary study so that you know this is what I have on site. This is the type of soil we have there. This is where the groundwater is. So when I'm designing for these conditions, right? So we'll have different apparatus that are used, and also there are different tests. They will be depending on what is it that is we are building on this particular site. The tests done, or even the depth that you look at when you are having mega structures and when you're just having a house will be different. Therefore, also the test that you really focus on whether that particular place has clay soil or it's a sandy soil, it might be different. In what way? If you are building maybe here in Durban, mostly is because the soil is not closely packed together, because of the sandy soil that they have. You focus more on reinforcements, right? On slope protection, because on most of their sites, they are in the slopey areas. So the investigation that you're doing in different areas will be depending on where is that area, and also geographically, do we have, what type of soil do we normally have there, right? So it's that kind of thing. If you're somewhere from maybe northwest, they don't worry about soil contents in water, because soil there, we're not looking at sand that has salt in it or anything. So tests that you will do here in KZN maybe, or mostly in Durban, or any place that is along the shore or the beach, will definitely be different from the tests that you will do maybe inland, right? So just take note of that. So that's a soil survey procedure. And then the other part is compaction. So we said that compaction is that process whereby we eliminate the voids to make sure that we get higher strength. So for you to get that higher strength, what do? You remove the voids. How do we do that? We use different types of machines, either rollers, tampers, or vibrators to compact the soil, or depending. So whether which equipment you're going to use will be dependent on what are you compacting and what type of strength are you expecting, or density rather, let's put it like that. What type of density, or the density that you're looking to achieve, then it will be based on that. For today, we will stop here. So from Thursday, we will go deeper into compaction so that you understand, and then we will move to quarries, stabilization, slopes, and the reinforced earth, right? In terms of what are we taking away from this lesson, the first thing is you need to know, why are you learning about soils? What do we use it for? How do you identify it? What sample are you going to collect? Will it be disturbed or undisturbed, and why? Why is it important for you to know or to regulate the amount of water when compacting? What is consistency, and why does it concern you when you're dealing with soils, right? What do they say about specific gravity and density? Is there a way to improve it? Yes. How? Compaction. Particle size distribution, we've already covered that. Why are we doing it? We do that because we want to classify, or we want to find out the type of soil we have, so that you can do what with it, so that you can make informed decisions based on whether the soil will be suitable for usage, or you need to kind of manipulate it and increase the strength or the density of that soil. So basically from my side on this chapter, just make sure that when you're going through it, right? You kind of don't just read it like you're trying to memorize each and everything. Read for understanding, because when you do that, it will not only help you, but it will also kind of help you when you are answering all the questions. So at the end of the day, it's important for you to kind of look at it like that. How then do you kind of know what to prioritize and what not to prioritize when you're reading? When you get that book, take it like a novel, right? Read it. Just read it and then go back to it again and make those smaller notes on the side. And ask yourself the why question. Why am I doing this? Because if you know when you're starting each and every section why you're doing it, it will always take you back to what are the things you need to take note of and highlight mostly when you're reading. So look at it like that. Let me stop the recording.